Today, we are going to dig into a scientific miracle that happens every single day, and it's something that sounds like straight-up magic, making food out of thin air. It's a process that's over 100 years old, but it's the reason nearly half the people on Earth can even exist. So let's get into the chemistry that feeds the world.
I mean, seriously, think about that question. It sounds like something out of a sci-fi movie, right? But it's not. I'm not kidding. We literally figured out how to turn the air we breathe into food. It's one of the most important breakthroughs in human history, and it all starts with the gas that's all around us.
So, here's the crazy part. Nitrogen is absolutely essential for all life. It's a key building block of DNA. And our air is 78% nitrogen. So you'd think, great, plants have all the food they could ever want. But they don't. For them, it's all locked up, completely useless because of one ridiculously strong chemical bond. And this whole situation has a name, the nitrogen paradox. You've got this element that promises life, it's literally everywhere, but it's just tantalizingly out of reach. For pretty much all of human history, this paradox is what held us back. It put a hard limit on how much food we could grow, and therefore, how many people could live on this planet.
Okay, so let's get a little geeky for a second. In the air, nitrogen hangs out in pairs, as N2. Now that connection between the two atoms isn't just a simple link, it's a triple bond. Imagine a treasure chest with 3 massive locks on it. It's one of the strongest bonds in all of nature, and breaking it requires a ton of energy, way more than any plant can manage on its own.
So humanity needed a key, or maybe a crowbar. We needed someone to figure out how to crack open that chemical vault, and in the early 20th century, a couple of brilliant minds finally did it. It all started with a German chemist, Fritz Haber. He's the guy who first cracked the chemistry in a small lab. But, a tiny lab experiment can't feed billions of people. That's where Bosch and the chemical giant BASF come in. They were the engineers who took Haber's idea and figured out how to do it on an absolutely massive industrial scale. The work was so revolutionary that both men ended up winning their own separate Nobel Prizes for it. And this is the secret sauce they created, the Haber-Bosch process. At its heart, the reaction is pretty straightforward. You take nitrogen from the air, you react it with hydrogen, and boom, you get ammonia, NH3. And ammonia is a form of nitrogen that plants can actually use. The real trick, the genius of it all, was finding the exact right conditions to make it happen. Insanely high pressures, super high temperatures, and a special iron catalyst to speed the whole thing up. This was the key that unlocked that nitrogen vault.
Okay, so that's the history lesson and the chemistry 101. But what does this actually look like today, inside a giant modern factory? Let's take a look. Whoa, okay, this looks like a lot, I know. But don't worry, we're going to break it down. Think of this as our map for the whole journey. It all starts with 2 main ingredients. Up top, we have natural gas, which gives us our hydrogen. And on the left, you see air, which is where we get our nitrogen. All those boxes in the middle are just a series of steps, cleaning, heating, squeezing, all to get those gases ready for the grand finale at the bottom, making ammonia. See? That whole complicated diagram really just comes down to 3 main stages. First, you gotta prepare the gases. You use steam to rip the hydrogen atoms off of natural gas, and you pull the nitrogen right out of the air. Second, and this is super important, you have to purify the mix. You've got to scrub out all the junk like carbon monoxide, because that stuff is like poison to the catalyst. It'll just stop the whole reaction cold. And finally, step 3, synthesize. The pure, clean mix of gases is pumped into a reactor for the main event, creating ammonia. And to make that last step work, you need some serious muscle. The conditions inside that reactor are just intense. We're talking pressures between 150 and 300 bar. To give you an idea of what that feels like, that's the same crushing pressure you'd experience almost 2 miles deep in the ocean. You need that immense pressure to literally force those super stable nitrogen and hydrogen atoms to finally get together and react. All right, so we've made ammonia gas. Mission accomplished, right? Well, not quite. Making the gas was the big chemical breakthrough, sure. But if you're a farmer, a giant high-pressure tank of gas isn't exactly easy to work with. So the process needs one more crucial step to get the fertilizer ready for the fields.
The solution is to turn that tricky gas into a stable, easy-to-handle solid. And the most common form, by a long shot, is a little white pellet called urea. This is the final product that gets shoveled into bags and shipped to farms all over the world.
And this is how they do it. It's a two-part trick, really. Over on the left, you've got the chemistry. Ammonia gets reacted with carbon dioxide, which is just a byproduct from earlier in the process, and that makes a thick, liquid urea solution. Now look at the diagram on the right. This is the physical part. That liquid gets pumped all the way to the top of a massive building called a prilling tower. It's sprayed out, and as the tiny droplets fall, they cool down and harden into those little solid pellets. Just like that, you go from a gas to a granule.
Okay, so we've gone from the tiniest molecule in the air all the way to a little solid pellet. Now let's zoom out and see just how huge this whole thing is on a global scale.
It's a pretty basic question, but the answer tells you everything you need to know. Where does all this stuff actually go?
I mean, just look at this. It's not even close. Agriculture completely, utterly dominates. A staggering 82% of all the ammonia made in the world goes directly into making fertilizer. And look at that biggest slice of the pie. Urea. Those little white pellets we just saw being made, they account for nearly half of all the ammonia produced on the entire planet.
Okay, so if the demand is that massive, who's making all of it? Well, it turns out one country is the undisputed king of ammonia production, China. They produce over a third of the world's entire supply. That is more than the next three biggest producers, India, Russia, and the United States, put together. This really just shows you how central ammonia is to their entire economy.
So let's just connect all the dots here. From cracking that nitrogen puzzle, to the Nobel Prize-winning breakthrough from Haber and Bosch, all the way to today's global network of enormous factories. This one single chemical process has become a pillar of our world. Without it, scientists estimate that our planet could only support about half of the people alive today. Think about that. The food on your plate tonight, there's a very good chance it exists because we figured out how to make food from air.
I mean, it's just incredible. This process literally changed the course of human history and allowed our species to flourish. But there's a catch. The Haber-Bosch process uses an insane amount of energy. It's one of the most energy-intensive industrial processes on Earth. And that raises a really big question for our future. What's the next food revolution going to look like? What will it take to feed the world tomorrow?